Download this code from codegive.com, link in the description below. OK, let's dive deep into pattern exploiting training, PET, for NLP. This will be a comprehensive guide, covering the concepts, advantages, limitations, variations, and, most importantly, a practical code example to get you started. What is pattern exploiting training, PET? Pattern exploiting training, PET, is a semi-supervised learning technique specifically designed for leveraging pre-trained language models, POMs, with limited labeled data. It aims to bridge the gap between the rich knowledge encoded in POMs and the scarcity of labeled data often encountered in real-world NLP tasks. Traditional fine-tuning of POMs requires a substantial amount of labeled data to effectively adapt the model to a specific task. PET offers a clever alternative by reformulating the task into a cloze-style question or a similar structured input that the POM is already well suited to answer. This reformulation leverages the masked language modeling, MLM, objective used during the pre-training of many POMs, like BERT, Roberta, Albert. Key ideas behind PET *. 1. Pattern definition. Task reformulation. The core idea is to define patterns that transform the input text and labels of your task into a form that a POM can easily process. These patterns are essentially templates with slots for the input text and a placeholder for the answer/label. 2. Label word mapping. Verbalizers. You need to map the original class labels of your task to specific words, or short phrases, that the POM is likely to associate with those labels. These mappings are known as verbalizers. 3. Training multiple PET models * to improve robustness and reduce bias. PET typically trains multiple models, each using a slightly different pattern. This ensemble approach helps to average out the noise and improve the overall performance. 4. Inference with ensembling * during inference, the predictions from all the trained PET models are combined, example by averaging the probabilities, to make a final prediction. 5. Self-training, optional in its original formulation, PET also involves an optional self-training phase. The ensemble of PET models predicts labels on a larger, unlabeled dataset. Then, these predicted labels are used to train a standard classifier, example fine-tuning the POM on these pseudo-labeled examples. This step can further boost performance. Advantages of PET *. Data efficiency * PET can achieve impressive performance with significantly less labeled data compared to traditional fine-tuning. It's a boon for low-resource scenarios. Leveraging POMs * it effectively taps into the knowledge already learned by the pre-trained language model during its massive pre-training phase. Interpretability, relative the patterns used in PET can sometimes provide some insight into what features the model is focusing on. Limitations of PET * pattern engineering * designing effective patterns and verbalizers can be challenging and require some trial and error. The choice of pattern can significantly impact performance. Computational cost * training multiple PET models can be computationally expensive, especially for large POMs. Sensitivity to verbalizers * the choice of verbalizers can have a significant impact on performance. Selecting appropriate verbalizers requires careful consideration. Task suitability * PET is most effective for tasks that can be easily reformulated into cloze-style or similar structured questions. It might not be as well suited for tasks requiring more complex reasoning or generation. The PET process, detailed. Let's break down the PET process step by step. 1. Data preparation *. You have your labeled dataset with inputs, text, and corresponding labels. Split the dataset into training and, optionally, validation/test sets. 2. Pattern definition, crucial step. Asterisk define a set of patterns that transform your input text and labels into a masked language modeling friendly format. Asterisk each pattern should have a placeholder, mask, for the word to be predicted. Asterisk example, sentiment analysis. Asterisk input, this movie was amazing. Asterisk label, positive. Asterisk pattern, this movie was text. I think it was masked. Where text is the input text. 3 Verbalizer definition asterisk. Asterisk create a mapping between your class labels and specific words, verbalizers, that the POM can easily associate with those labels. Asterisk example, sentiment analysis. Asterisk positive dash great. Asterisk negative dash terrible. For model initialization asterisk. Asterisk instantiate the pre-trained language model, example bert, roberta. Asterisk also, create a tokenizer that corresponds to the chosen POM. 5 Pattern training asterisk. Asterisk for each pattern. Asterisk format the training data asterisk transform your training examples using the pattern and verbalizer. For example. Asterisk original example, this movie was amazing, positive. Asterisk transformed example, this movie was amazing. I think it was masked. Target, great, because positive maps to great. Asterisk fine-tune the POM asterisk train the POM to predict the masked word using the formatted training data. You're essentially teaching the model to associate the input text with the correct verbalizer. Asterisk masked language modeling loss asterisk use the masked language modeling loss to train the model. The goal is to minimize the difference between the model's prediction for the masked token and the correct verbalizer word. 6 Ensemble training, multiple patterns. Asterisk repeat step 5 for each defined pattern. You'll end up with multiple trained pet models, one for each pattern. 7 Inference asterisk. Asterisk for each input example you want to classify. Asterisk format the input asterisk transform the input using each pattern. Asterisk make predictions with each model asterisk use each trained pet model to predict the probability distribution over the vocabulary for the mask token. Asterisk convert probabilities to label probabilities asterisk for each pattern, extract the probabilities associated with the verbalizers corresponding to your class labels. For example, asterisk if your verbalizers are great and terrible, extract the probabilities predicted for these 2 words. Asterisk aggregate probabilities asterisk average, or otherwise combine the label probabilities from all the patterns to obtain the final prediction. The class with the highest combined probability is the predicted class. 8 Optional self-training asterisk. Asterisk predict labels on unlabeled data asterisk use the ensemble of trained pet models to predict labels for a large unlabeled data set. Asterisk filter pseudo-labels asterisk apply a confidence threshold. Only keep examples where the ensemble of models predicted a label with high confidence. Asterisk train a classifier asterisk train a standard classifier, example fine-tuning the POM again, but this time on the pseudo-labeled data, using the pseudo-labeled examples as training data. This can further improve performance. Code example, simplified, using Hugging Face transformers. This example demonstrates a simplified version of PET for sentiment analysis using BERT. It focuses on the core concepts of pattern definition, verbalizers, and model training. It skips the self-training part for brevity. Explanation of the code asterisk. 1 Data asterisk a small example dataset of sentiment analysis examples. 2 Pattern and verbalizer asterisk defines a simple pattern and verbalizer mapping positive/negative sentiment to great and bad. 3 Model and tokenizer asterisk loads a pre-trained BERT model and its tokenizer from Hugging Face transformers. Critically, We're using BERT for masked LM. For PET dataset asterisk a PyTorch dataset class that formats the data according to the pattern and verbalizer. It tokenizes the input text and finds the index of the mask token. 5 data loader asterisk creates a data loader to iterate through the dataset in batches. 6 optimizer asterisk uses the atom W optimizer to train the model. 7 training loop asterisk iterates through the data, feeds it to the model, calculates the loss, and updates the model's weights. The core of the PET training is happening here. Asterisk outputs equals model, input underscore ids, attention underscore mask equals attention underscore mask, labels equals input underscore ids, important for masked language modeling. Labels equals input underscore ids tells the model to treat the input tokens as the target labels. Asterisk we extract the logits for only the mask token. The loss is calculated by comparing these logits with the target token, the verbalizer word. 8 inference asterisk a predict underscore sentiment function that takes a text input, applies the pattern, and uses the trained model to predict the sentiment. It converts the model's output into probabilities for the verbalizer words and chooses the sentiment with the higher probability. We use torch.no_grad to disable gradient calculation during inference. 9 testing asterisk demonstrates how to use the predict underscore sentiment function on a test example. Important notes and improvements asterisk. Asterisk multiple patterns asterisk this example uses only one pattern for simplicity. In practice, you should define multiple patterns and train multiple models. You would then average the predictions from these models during inference. Asterisk verbalizer optimization asterisk experiment with different verbalizers. The choice of verbalizer can have a significant impact on performance. You could try good instead of great, for example. Asterisk hyperparameter tuning asterisk adjust the learning rate, batch size, and number of epochs to optimize performance. Asterisk evaluation asterisk use a held out test set to evaluate the performance of your PET models. Asterisk self-training asterisk implement the self-training step to further improve performance by leveraging unlabeled data. Asterisk task-specific patterns asterisk design patterns that are specifically tailored to your task. Think about the types of questions or statements that the POM would be good at answering. Asterisk consider using the fill mask pipeline asterisk Hugging Face Transformers provides a pipeline function called fill mask that can be useful for prototyping and quickly testing different patterns and verbalizers. However, for more complex PET setups, you'll likely need to implement the training loop yourself, as shown in the example. Asterisk experiment with different POMs asterisk try different pre-trained language models, Roberta, Albert, etc., to see which one works best for your task. Asterisk handling more complex tasks asterisk for more complex tasks, example question answering, text summarization, the patterns and verbalizers will need to be more sophisticated. Asterisk regularization asterisk consider adding regularization techniques, example weight decay, to prevent overfitting, especially when using small data sets. In conclusion asterisk. Pattern exploiting training, PET, is a powerful technique for leveraging pre-trained language models with limited labeled data. It requires careful pattern engineering and verbalizer selection, but it can achieve impressive results in low-resource scenarios. This tutorial provides a solid foundation for understanding the core concepts and implementing PET for your own NLP tasks. Remember to experiment, iterate, and tailor the technique to your specific needs. Good luck.